Let's talk about proportions. A proportion is just the statement that two ratios are equal. For example, the equation or statement 2:3 equals 10:15 is a proportion. The fraction 2/3 and 10/15 are equivalent. So a proportion is just a statement that two ratios are equal, or that you could reduce one ratio to get the other. When we have proportions, the cross products are always equal. That means if I multiply, in my example, the number 2 by 15, I should get the same product as taking 3 times 10. And in this case, that is true. 2 times 15 is 30. 3 times 10 is also 30. That is always true with proportions. And we can use this fact to solve proportions that have unknown values. Here's an example. Find the missing value in each proportion. So I have the statement x is to 15 as 36 is to 20. I want to figure out what x is. I'm going to start by setting my cross products equal. So again, anytime we have a proportion, so here I have an example just in generic terms, A is to B as C is to D, we can always set the cross products equal. We can say A times D equals B times C. So in this case, that would be x times 20, so 20x, equals 15 times 36. 15 times 36, let's see, 6 times 5 is 30, so I carried the 3. 6 times 1 is 6, plus 3 is 9. Add a 0. 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. Add those together and I get, let's see, 90 plus 450 is 540. So my equation is 20x equals 540. Now we can solve for x because it's 20 times x. We have to divide both sides by 20. Dividing by 20 isolates the x. 20 divided by 20 is 1, so we can just cancel out those 20s on the left-hand side. On the right-hand side, we've got 540 divided by 20. Before I do this division, since both of these numbers end in 0, they're both divisible by 10. So I'm just going to kind of cancel out a 0 there, divide both those numbers by 10. So now I've got x equals 54 divided by 2, which is 27. And that's my final answer. X is 27. Here's another example. It looks a lot more complicated with these fractions, but we're going to go through the same process. To find the missing value, the first thing we're going to do is set our cross products equal. So we're going to take 1 1/10 times x equals 2 1/3 times 11/7. So I just set my cross products equal. Then I'm going to go ahead and change all my mixed numbers into improper fractions. 1 times 10 is 10, plus 1 is 11. So 1 1/10 is 11/10. 2 times 3 is 6, plus 1 is 7. So 2 1/3 is 7/3. And then 11/7, I can just leave that as is. I'm going to multiply the two fractions on the right-hand side. To multiply, we can go straight across, but I notice right away that there's a common factor of 7. I can just go ahead and cancel those out, and I'm just left with 11/3. So 11/10 x equals 11/3. To solve for x, again, the x is being multiplied by 11/10, so I have to divide by 11/10. This is the exact same process we used in the previous example. Dividing by 11/10 on the left-hand side will isolate that x. So we also have to divide by 11/10 on the right-hand side. To divide by a fraction, we copy, dot, flip. We multiply by the reciprocal. So I'm going to take 11/3 times, and then I flip, and I get times 10 over 11. I can multiply straight across. Although I do notice there is a common factor of 11, we might as well cancel those out before we multiply, and now we're just left with 10/3. And that's my answer. X equals 10/3. Let's do one more. Find the missing value in the proportion. Exact same process. We are going to set our cross products equal. So I'm going to take x times 0.4, and that's going to equal 7 times 2.4. Then I'm going to go ahead and multiply 2.4 times 7. 7 times 4 is 28, carry the 2. 7 times 2 is 14. Plus 2 is 16. And then the product has one digit after the decimal. So the answer can have only one digit after the decimal. So that becomes 16.8. So 0.4x equals 16.8. Now, same process as before. To get the x by itself, we have to get rid of the 0.4. So I'm going to divide both sides by 0.4. That's going to allow me to cancel the 0.4s out on the left-hand side. And so x is going to be whatever 16.8 divided by 0.4 is. To do this division, I want to clear the decimal in the denominator. So I have to move the decimal one place over to get rid of it. And I have to make sure I do the exact same thing on the top. Technically, I'm multiplying the top and bottom by 10. But you can think of it as however many places you move the decimal in the bottom number, you have to do the same thing to the top number. So this turns into 168 divided by 4, and that quotient is 42. And that's my final answer. X equals 42. Proportions can also be used to solve application problems. And so I want to run through a couple examples of some applications. Here's the first example I'm going to do. On an architect's blueprint, 1 inch corresponds to 6 feet. Find the length of a wall represented by 4 1/3 inches on the blueprint. The key to solving an application with a proportion is to really keep track of or pay attention to the units. So in your proportion, there will always be two numbers that are given to you that go together. In this case, 1 inch corresponds to 6 feet. So I'm going to start by writing the two numbers that go together as a ratio, and I'm going to put that on one side of my proportion. 1 inch goes with 6 feet. Notice that I wrote down the units as well. And that's because when I write down the other side of my proportion, the units have to be the exact same. So since I put inches on the top on the left, I have to put inches on the top on the right. Feet are on the bottom on the left, so feet go on the bottom on the right. Now the problem says find the length of a wall represented by 4 1/3 inches. The units, that inches, tells me that the 4 1/3 goes on the top on the right side of my proportion. That means my unknown, my x, has to go on the bottom of the right side. And there's my proportion. 1 inch goes with 6 feet, and that's going to equal 4 1/3 inches goes with how many feet? Now we can solve this problem exactly like we've done the previous examples. We can take our cross products. So we can take 1 times x has to equal 6 times 4 1/3. So this equation is almost already solved. 1 times x is just x. So I have to take 6 over 1, and then 4 1/3. I'm going to change that into an improper fraction. 4 times 3 is 12, plus 1 is 13. So 4 1/3 is 13/3. And then we can just multiply straight across. Although 6 and 3 are both divisible by 3, 3 divided by 3 is 1, 6 divided by 3 is 2, and now if I go straight across, 2 times 13 is 26 over 1. Oh, so 26. So my final answer here is 26 feet. So that wall must be 26 feet long. Let's do one more. A recipe that requires 3 cups of sugar to make 18 servings is to be used to make 45 servings. How much sugar is needed? So once again, in this problem, there are 2 numbers that go together. They're telling us 3 cups of sugar makes 18 servings. So I'm going to write that as a ratio, and I'm going to put that on one side of my proportion. I'm going to write down the units to help me keep track. 3 cups goes with 18 servings. This means when I write the other half of my proportion, cups has to go on top, servings has to go on the bottom. We want to figure out how much sugar is needed to make 45 servings. That tells me I'll put the 45 on the bottom, that's servings. And we're trying to find the amount of sugar, so the x goes on the top with the cups. Now we can solve this just like the other problems. 18 times x has to equal 3 times 45. 3 times 45, let's see, 3 times 5 is 15, carry the 1. 3 times 4 is 12, plus 1 is 13. So 3 times 45 is 135. And then to solve for x, I'm going to divide by 18. 18 goes into 135. This one, if you don't have a calculator, might take a little trial and error. But it turns out 18 goes in 7 times. And 18 times 7 is 126. So I have a remainder of 9. So I think I'm going to write this as a fraction instead of a decimal. So we've got 7. 9 is the remainder. So 7 and 9 eighteenths. 7 and 9 eighteenths. And 9 eighteenths reduces down to a half. And so my answer is 7.5 cups of sugar are needed. That was my last example. As always, reach out if anything is unclear.